The smallest inset is 1/21st, the smallest tile. Therefore, this is actually what I would expect. Let's look at the math. In shader source fragment number 5, we have added the internal coordinate of a tile, the discrete tile local xy, upper and lower bound, and then an out of bounds flag. And we're going to use that to render the tiles as inset. Inside of our back to front rendering loop, this section we added in 191, we're now filling it out. We have a define for the discrete unit inset for the current layer we're on, a little diagram to help us make sure our math is pixel perfect, our pixel perfect lower and upper bounds. Then this is a coordinate local to the internals of the tile. So we're going to take the current tile we're on, multiply by the tile span for the current tile size, and we're going to take this amount and chop it off of the level local chord to get this tile internal local chord. Once we have that internal chord, we want to know if we're out of bounds. So we have this logic here to check to see if the coordinate is out of bounds of the tile when we're applying an inset. If we are not out of bounds, we're going to keep the data. We're going to carry over the data. So this is our set of data for every single tile, the binary data for the tile. If we are out of bounds, then we are going to erase the binary data for the tile. If we erase the binary data for the tile will not render. And that will effectively create our insetted part of the tile. Here's where we're clobbering everything together. So if any tile exists on any layer for the current sample point, then we are going to see some type of detail. And that is why we only see these edges around the largest tile size. Here's what we did previously. Here are some observations, and here's what we did in this video. You've been on this playlist right here. If you want me to go into more detail, you can go here. You can get the source code here, email me here. This has been video 192. Like and subscribe.